Hey Renee, I was thinking, what is sound exactly?
Sound is a longitudinal wave. This means that the wave is closer together in some areas, but farther apart in other areas.
So it can compress and lengthen?
Precisely. When a sound is made, air is pushed together by a lot or a little, creating a wave.
Now, I know there's such a thing as a speed of light, but is there a speed of sound?
There is. However, the speed of sound, unlike the speed of light, is dependent upon a few factors.
Such as...
Well, for one, the temperature. If the temperature is higher, the speed of sound will be faster. This is because the particles at higher temperatures are moving faster, and sound travels more efficiently through faster moving particles. Also, sound travels through all mediums, solids, liquids, and gases. The speed of sound is quickest through solids, then liquids, then gases.
Why is that?
In solids, the particles are packed together. These particles transfer sound to surrounding particles more efficiently since they are close to one another.
So that's why you can still hear underwater, but it sounds kind of distorted. Now, I know that nothing is faster than the speed of light, but I assume things can go faster than the speed of sound.
Yes, in fact, several applications can travel faster than the speed of sound. For example, an airplane. When it travels through the air, it makes sound waves. If the plane is traveling faster than the speed of sound, then the sound wave can be promoted ahead of the speed of sound. This is known as breaking the sound barrier and creates a sonic boom.
This applies to a whip because the tip of it can travel faster than the speed of sound. That is why there's a cracking sound. Now, you discussed how the wave is longitudinal, bigger in some areas and smaller in other areas. How does this affect it?
The amplitude of a sound wave refers to how tall the wave is. The loudness of the sound is directly related to the amplitude. The louder the sound, the bigger the amplitude. If the frequency of a sound is about 111 decibels or more, permanent hearing loss could occur.
Hearing loss, huh? How would that happen?
Well, let me briefly discuss how the ear works. Sound vibrations enter the ear and come in contact with the eardrum. The vibrations that hit the eardrum are sent down to the auditory nerve to the brain and interpreted as sound. Hearing loss can occur if a part of the ear is damaged and the brain can no longer interpret the wave as a sound.
So if the wave is taller or smaller, that is loudness. What happens to sound when the wave is compressed or lengthened?
What you're referring to is frequency, or the wavelength. Frequency is measured in hertz, and different frequencies are heard by different species. Humans hear in sonic. This is about 20 to 20,000 hertz. Infrasonic is 0 to 20 hertz. That is a very low frequency, and the sound wave is lengthened a lot. Animals such as elephants communicate in infrasonic. We cannot hear this, but sometimes we can feel the rumbling or the vibrations of the sound waves going through our body.
Okay, if infrasonic has a lower frequency than sonic, is there anything with a higher frequency than sonic?
On the other end of the scale is ultrasonic, which is above 20,000 hertz. This is very high frequency, again, one in which we cannot hear. Unlike infrasonic, ultrasonic has sound waves that are very compressed. Animals like dogs can hear these very high frequencies.
Oh, okay. So that's why when a dog whistle is blown, we cannot hear it, but the dog immediately responds to it.
The auditory nerve is sensitive to certain frequencies, so we can hear some frequencies and not others.
Wow, I never knew there was that much to do with sound.
We rely on it every day, and it is so important to our lives.